Hello, welcome back. This is going to be part 4 video, and it's going to be on strand E, subscript A. Is that making you dizzy? It's making me dizzy too. Okay, first slide. Right, normal rules apply. What we want to do is we want to meet all the criteria here, meet them there, meet the last one and this final one here. We're working away across here because we want top marks, which is 8 marks. So how are we going to do that? Let's start at the bottom. We've got the first one. So the first one says we need to make relevant comments about the problems encountered whilst collecting the data. This is why you do a preliminary set of results. This will inform you and allow you to talk about all the little problems and little niggles. But you don't want 1 or 2 marks, you want 3 or 4 at least, so we're going to have a look at this section here. It says describe the limitations imposed as opposed to just talk and moan about all the problems that you had. So what are the limitations? Well, let's suppose, we'll make something up, let's suppose when you were connecting up item A to item B in your experiment, item A being whatever you want, item B being some other piece of equipment, maybe that you had some sort of problem when you were connecting them up, and you need to say why. What did it cause a problem? Maybe it caused you problems in a time delay, maybe some gas escaped, maybe it's difficult to take accurate readings initially when you're connecting them up. You've basically got to make some sort of comment on the limitations. Okay, let's just clarify. It's got to be the techniques or equipment. So the technique is basically what you do, your method, how you put things together. Okay, and the equipment is obviously the bits of kit in front of you. So either and or both of those to get your 2 to 3 marks. Well, obviously you're still here. You don't want 2 or 3 marks. You're after a minimum of 5 or 6. Okay, so what we need to do is we need to figure out how we're going to get 5 or 6. It says that you need to talk about the improvements, either in the apparatus or the techniques. Either one of those or both is good. Okay, maybe even an alternative way of collecting them. So there may be a different set of equipment you may think of that wasn't made available to you, or an alternative way of collecting the data. You'll notice here it says outline. So we've just kind of briefly mentioned them, that you into the 5 and 6 territory, but obviously we want to get you to the 7 or 8. Right, 7 or 8. We're still talking about apparatus and or techniques. Really depends on what investigation you're doing, whether it's you can get something for both or one or the other. Then what have we got to do? The apparatus or technique, you must say how you would use the equipment and how it would improve your investigation. That's going to get you 7 to 8 marks. So don't forget, the point is it says describe in detail. So if you just kind of give an outline, you're just going to get this. Describe in detail. Okay, we're now on E subscript B. So in a nutshell, let's just run through what this set of criteria mean. This part, make a claim for accuracy or repeatability. You're basically saying, yeah, my results are good, or my results are bad, or they're not very good at all. This one, you're basically talking about outliers. Okay, that's where you get a strange result out here. This could be your results down there, mostly down here, clustered along line of best fit, something like that, but you get something like that. You might have a result down there. That's what I mean by that. So that's an outlier. The next one is where you're looking at the pattern of results, so I'll explain that in a second. Down here, pattern results, and this is to get the 7 or 8. Consider critically the reliability of the evidence accounting for any outliers. It's basically this, but you've got to go into some detail. You've got to be very thorough looking at your results and state how good the results are in your experiment. Okay, I've spoken about making a statement. Don't need to really go into any more detail about an outlier or an anomalous result. What I need to go into some detail now is looking at the graphs that you have and you making a comment about whether you think there is a pattern of results there. What I will be doing is I'm not going to be drawing the average result and the upper result and the low result like that. For the sake of this explanation, I'm just going to draw a line like that. So when I draw this line, that obviously is the average and a small amount of scatter. Look, I'm struggling to even draw it with this. If I draw a long line, what I obviously mean is the average and a large amount of scatter. So I'm not going to do the whole cross and maximum minimum, I'll just draw a line. So let's say that we have something like a whole load of scatter like this. You've got a whole load of lines like this. Fairly obvious that it's very difficult to figure out, whoops, not that one. Okay, it's fairly obvious that if I can get that line again, that what I'm trying to do is get that over there. Okay. You can see from this amount of scatter, it's very difficult to establish where the line of best fit is. It could be at one extreme, it could be there, it could be down here, it could be there, it could actually be going the other way, couldn't it? So there's a whole range of places where this line of the real line, the actual true value, could be. So this is not good data. So you'd have to say that you're not particularly confident because the line of best fits, the line of best fit, it's not clear where it should go. Your error bars are very large and the data is not particularly good. You could have some data that is, in fact, a lot better. So let's say we had some results like this. With this data, you'd obviously be saying that this result is a whole lot better. So you've got good results. So, and if I can pick this up. Right, here we go. There she goes. So with this one, we can say that the line of best fit is going to be somewhere around here, and you can tell from this line of best fit and the error bars that you can be fairly confident that the true value is probably somewhere around here. So you need to state that. You say you've got nice small error bars, the line of best fit went through the error bars, so maximum would be this way, that would be kind of the minimum that way. Okay, so this will be a good set of data. So don't forget that this is the language that you need to use. So you can say that your amount of scatter, which is these error bars, okay, in this particular case is quite low. You very easily got a line of best fit, and that you believe that the accuracy and repeatability of your experiment is very good, as opposed to the earlier example where I said it was very bad. So you need to judge this based upon how good your error is with your error bars. Okay, if they're kind of like this, like that, you'd have a lot of data, but you can't be too confident what's going on there. So that's what you need to do, and you need to talk about that in great detail to be able to get the top mark. So note here as well you've got to account for any outliers. So let's say with this particular data, which you've been saying how great it is, but you had one set of data here, this you've got to account for. So you need to say what caused this outlier or anomaly. It means the same thing in this context at key stage 4. Okay, well done. That was the end of part 4. Go and have a cup of tea and a biscuit and come back later for part 5.